Hello, students. Today, in this lecture, we are going to start with numerical methods, the module 5. I'm going to deal with module 4, which is uh, slightly difficult compared to module 5. In the once I complete module 5, as you know, we have to complete the portions by May end by the instructions of the higher education minister. So in this module 5, we are going to study numerical methods. Actually, the numerical methods deals with the situation wherein the analytical result is not possible. Like if I consider, if I give you a simple equation, the x squared plus 2x plus 1 is equal to 0. See, x squared plus 2x plus 1 is equal to 0. Find out if I ask you to find the roots. So it's very easy, as you know, x squared plus 2x plus 1 is x plus 1 whole square. So naturally the answer is x is equal to minus 1 and minus 1. So within no time, see, even I did not require the board or paper or pen to solve such equations. See, if I say similarly, sine x is equal to 0, solve this. If I ask you to solve this equation, then it's very easy. X is 0 or x is n pi, because I know sine n pi is 0. So like this, see, these are called as analytical methods. You can apply certain rules, you can apply certain formulae, and if you can apply certain methods, and you can find out the solution directly. Right? Here, in the case of x squared, if I give you the example like this, x squared minus 1 is equal to 0. So what are the solutions? So this gives you x squared is equal to 1, or x is square root of 1 is either plus 1 or minus 1. So like this, you make use of basic rules and basic rules of math, and you solve those equations. So these are all called as analytical methods. See, if the problems are simple, I can use analytical methods and I can find out the solution. Right? Suppose if the problem is complex, say if I give you a problem wherein all the expressions like exponential, logarithmic, trigonometric, all sort of expressions are there. Say e raised to x times x squared plus x sine x plus cos x is equal to 0. If I give you an equation like this, it's not possible easily. That there is no definite way to solve such equations. So the direct methods, or I can say the analytical methods, are not possible in solving such equations. Right? In such cases, we go for numerical methods. Right? So this is one example that we are going to study in Unit 2 here. See, in here, solution of polynomial and transcendental equations. So those how we solve such complicated or complex equations in section 2 or unit 2 of this module, subunit 2 of this module. See, in numerical integration, suppose if I consider dx over x, it's easy. See, if I consider dx over x cube plus 1, not that easy. If I give you a problem, e raised to x divided by e raised to sine x plus tan x dx, if I ask you to integrate, not easy. So in such cases, we go for numerical integration. It's very simple, like using numerical integration. We can easily solve such complex integrals. Then coming to that we are going to cover in section 3 of module 5. Then coming to the section 1 of module 5. See here, see, we consider the cases like, see, if you are given a function, and if you are given the points x0, x1, x2, x3, so on up to xn, that That is, if you are given n x values, I can find out corresponding n y values. That is for x naught, y naught for x1, y1 for x2, y2 like that for xn, yn. That is given a function. If I know the function, I can easily tabulate x naught, y naught, x1, y1, x2, y2, so on up to xn, yn. Right. But here, in most of the experiments you do, you get set of tabulated data. You do not know the function here. See, in my earlier case, what I said, if you know the function y is equal to fx, I can have set of tabulated data x naught, y naught, x1, y1, x2, y2, so on up to xn, yn. But here, there is no function. That is, function is not known to you, but in an experiment, you have what? A set of tabulated data. Say, x at t is equal to t naught, what is the velocity? At t is equal to t1, what is the velocity? If I consider simple pendulum experiment, or if I consider a body which is falling freely from the space, or if you consider a vehicle moving with a speed. So in all these such experiments, what you do, you measure certain, you observe certain results at some fixed points of time. Say maybe at t is equal to 0, what is the velocity, what is the position, or so at t is equal to t1, what is the position or what is the velocity. So like that, you will have set of different values, right? Set of values taken at fixed intervals of time or fixed length of time, right? For different values of t. That is, you know, set of values at t naught, v naught, at t1, v1, at t2, v2, like that. So you will have certain set of values. In mathematical terms, what I say is, in an experiment, I got a value like x naught, y naught, x1, y1, x2, y2, so on, xn, yn. That means I know the n tabulated points now, right? Now I do not know the value of the function here. I do not know the function here at all. I got what are these points? They are the results of an experiment. That's all I can say. Now, since I do not know the function, it becomes difficult for me to find out some intermediate values. To find out certain set of non-tabulated points. Finding out such a thing is called a simulation in the experiments in physical terms, or in real terms. They say simulation. So here, what if I ask you to find out the value of x at certain non-tabulated points, right? Your experiments are over, and you cannot repeat. You have to repeat the experiment to find out the value of x in if I do not have the formula, right? But in finite differences, that is in interpolation and extrapolation, using certain techniques, knowing all these n points, I can still find out the value at unknown point x or untabulated point x. That's what is called as interpolation. Interpolation and extrapolation, they are the same words. Like if I give you the point to be at which the value to be find out, if it lies within x naught to xn, that is, if it is greater than x naught and less than xn, then we call that as interpolation. It lies within x naught to xn. Suppose if the point asked, the x, which is the point asked, is lies outside the interval, say x naught to xn. If it is greater than xn and if it is less than x naught, then we call such finding out such values, we call such processes as extrapolation. They carry the same meaning, right? Same meaning in the sense, if the point x at which I want you to find out y lies within x naught to xn, it is interpolation. If it lies outside x naught to xn, that is called as extrapolation. So such things we are going to study in finite differences, that is section 1 of numerical methods. It's very easy. All these things are very easy, and even the Even the syllabus requires you just to know the formulae and apply them. So all these, see, you should know what is finite difference, and you should know what is forward and backward difference in unit 1, and you should know what are the formulae, Newton's forward difference formula, what is Newton's backward difference formula, what is Newton's divided difference formula, and what is Lagrange's formula. So you need to know these formulae, and you should know how to apply these in finding out interpolation and extrapolation. Right, on the similar lines, in solution of polynomial equations, you should know what is Newton-Raphson method, and you should know what is regular falsy method. That regular falsy method is also called as false position method, right? So you should know how the formulae, and you should apply these formulae to solve the problems. Similarly, Newton's integration, clearly they mention without proof, right? So all these things you should know the formulae, and you should apply these in solving the engineering problems. So this is brief about module 5, and I'm going to start with finite differences.